Hey there, 6th grade. In this next video, we're going to learn about circles, and we're going to look at the different parts of a circle and how to name those different parts. So a circle is just a set of all points in a plane that are the same distance from another point, which we call the center of the circle. And the center is how we name circles. So if you look at the circle I have drawn below, its center is the point O. And so we would name this circle Circle O because that's its center. And then I have a few other parts of the circle drawn in that we're going to define and label now. The first part I want to talk about is what's called an arc. An arc is just a part of the circle. It's named by its endpoints. And so, for example, if I were to draw the part of the circle that goes from point P to point Q, this is an example of an arc of the circle. And we would call this arc PQ, which with symbols looks like this with a little arc drawn above it. Okay, sort of like how you identify a line segment, except we're drawing a arc instead of a bar above the PQ. Next, we have what's called a radius. A radius is a line segment whose endpoints are the center and any point on the circle. So the radius itself is not a part of the actual circle, but it has an endpoint on the circle. So in this picture here, we have a radius drawn that goes from the center O to the point C, which is on the circle. So this line segment OC is an example of a radius of this circle. Next, we have diameter. The diameter of a circle is also a line segment, but it's a line segment that passes through the center, and it has endpoints that lie on the circle. So again, in this diagram, there's a diameter drawn. The diameter is the line segment that goes from point A to point B and passes through point O, which is, again, the center of the circle. So this is the diameter of the circle. And then finally, we have what's called a chord. A chord is a line segment whose endpoints are any 2 points on the circle. So the difference between a chord and a diameter is a diameter has to pass through the center, a chord does not. For instance, I could draw a line segment from point Q to point C, and this line segment QC is what's called a chord of the circle. So it doesn't have to pass through the center, unlike the diameter. Okay, so in examples 1 through 3 now, we're going to practice naming the parts of circle P here to the right. So number 1 asks us to name the radii, is how you say this. This is the plural of radius. Okay, so we're going to name any radii we see. Remember, a radius of a circle is a line segment from the center to any point on the circle. So let's see what radii we can find. Well, I see one line segment that goes from the center, point P, to point A. So this line segment here, line segment AP, would be considered a radius of the circle. There are other line segments, though, that do the same thing. For instance, line segment BP from the center to the point B is also a radius of the circle. Line segment CP is also a radius of the circle. And then line segment DP is a radius of the circle. So circles can have more than one radius, and a radius, again, just has to be any line segment drawn from the center to a point on the circle. So here in this figure, there are 4 that are drawn there. Next, we're asked to identify any diameters of the circle. there is only one diameter drawn, and the diameter is the line segment from B to D. Remember, a diameter has to have endpoints on the circle, and it has to pass through the center. And so line segment BP is the only line segment that does that here. Finally, we're asked to identify chords. Chords are any line segments that have both endpoints on the circle. So the first chord I see is line segment AD. So that would be a chord of this circle. Next, I see line segment CD. That's another chord of the circle. Line segment AB is a chord, as is line segment BC. There is one more chord on the circle that may not be obvious right away, but the diameter itself is also a chord. Okay, the diameter from B to D is a chord because, again, it has endpoints that are on the circle. So the diameter itself can be a chord. And I just noticed that up here, this should say BD, not BP. Make sure you fix that on your notes, please. That's line segment BD for the diameter. Okay, let's go to the next page now and talk about a couple of more vocabulary words dealing with circles. A central angle of a circle is an angle that is formed by two radii. So, for example, in this diagram, notice there is a radius here and a radius here. The angle formed by these two radii is what's called a central angle of the circle. A sector of a circle is the part of the circle enclosed by two radii and an arc connecting them. So if you look at the two radii I drew here in red, there is an arc here from this endpoint to this endpoint. And so everything in between the radii and the arc, which would be this region here, is what's called the sector. Okay, this is a sector of a circle. Think of it like a piece of pie. Okay, if you cut a piece of pie out, that piece itself is what's known as a sector. The sum of the measures of all of the central angles in a circle is 360 degrees. If you added up all of the central angles of a circle, this angle plus this angle plus this angle plus this angle in this picture, their sum would be 360 degrees. And so for that reason, we say that there are 360 degrees in a circle. Okay, so in example 4, to the right you have a circle graph that uses a penny as the circle, and it shows the results of a survey to determine how people feel about keeping the penny. And what the directions ask us to do is find the central angle measure of the sector that shows the percent of people who are against keeping the penny. Okay, so for this problem you have to know some vocabulary. So first of all, you're asked to find a central angle measure. And remember, central angles are formed by two radii. So there are three central angles shown in this picture. There's this central angle, there's this one, and then there's this large obtuse angle here. We're supposed to find the angle measure of the central angle that shows the percent of people who are against keeping the penny. And so the against part of this circle graph would be this part here. And so we need to find the angle measure of this central angle here. Well, in order to do that, we need to know a little bit about percents and then a little bit about how many degrees a circle has. So up here, we talked about a circle has 360 degrees. And we know this sector that I highlighted in purple represents 32% of the people surveyed. So 32% of this circle is people against keeping the penny. So that means that the angle measure of this central angle is 32% of 360 degrees. How do we find 32% of 360 degrees? Think back to our percents unit. I can take 360 degrees times 0.32, because 32% as a decimal is 0.32. So when I do that, I'm going to get out my handy-dandy calculator. 360 times 0.32 is equal to 115.2. So that means that this angle that I've highlighted in purple, that central angle, is 115.2 degrees. Okay, if you had any questions over this video, 6th grade, make sure those are written down for the next time. And until then, have a nice day. You're all wonderful people. Take care.